Hello, and welcome to More Science in Your Fiction with LXS and Friends at Comic-Con at Home 2021. My name is Karen Martin. I run a nonprofit called Princess Project San Diego, and it is an honor and pleasure to be a moderator for today's panel. Before I introduce our amazing panelists, I wanted to take a moment to talk about the League of Extraordinary Scientists and Engineers and its founder, Jean Wong. Jean is extremely passionate about equity in education and about encouraging young minds to constantly learn and discover new things. In order to bring the love of science to children in underserved communities, Jean and a group of amazing people came together to create the nonprofit LXS. And when the pandemic shut the world down 15 months ago, Jean, in true superhero form, sprung into action. And with her team, worked tirelessly with teachers, scientists, and community to help create free online programming and content to reach kids during the lockdown. She worked so hard, in fact, that she's taking a small break to spend some very well-deserved time with her family. And I just wanted to take the time to acknowledge Jean and all of her hard work and efforts with LXS. And today, you're going to be meeting some amazing scientists and friends of LXS. And without further ado, I'd like to introduce today's panel. First, marine biologist Ben Frable of Scripps Institute of Oceanography. Dr. Sunny Fugate, the Technical Director of Cyber Warfare. Dr. Alyssa Griffin of Bodega Marine Laboratory at UC Davis. Sara Huber, also known as Cali Water Girl, Water Resource Control Engineer. The viral ecologist, Dr. Lisa Zeigler. Angela Zoumplis, extremophile explorer with Scripps Institute of Oceanography. And Chris Neuhahn, Emmy-winning animator, producer, and writer. We'll have each of our guests speak for a few minutes about what they do, and then we're going to open up for a little Q&A and conversation. Our first speaker is going to be Ben Frable, and Ben, you have the floor.
Yeah, hi everyone. As Karen said, my name is Ben Frable. I'm a marine biologist, and specifically I'm an ichthyologist, and this is the term for somebody who studies fish and fish evolution. My job is collection manager of the marine vertebrate collection at Scripps Institution of Oceanography here in San Diego. And so pretty much what that is you can think about it like a library, but instead of books, it's preserved fish specimens. So here at Scripps, we have about 2 million or so preserved fishes in about 140,000 jars, representing about 6,000 different species. The fish that have been collected all over the world by researchers, members of the public, and other folks over the last 150 or so years. And what my job is to make that large collection of material accessible to scientists, artists, students, and educators like Jean, and folks all over the world, whether they're visiting us or using things remotely. Beyond that, I do a lot of research. I primarily study fish evolution and do a lot of work on figuring out the species boundaries of fishes, like describing new species of fish, which is really cool. We get to name new things. You know, I kind of had this idea that all the species had already been discovered at some point, but that's not true at all for fishes. So it's really exciting. And doing that kind of work, working on all sorts of different types of fish as well. I work on coral reef fishes. This is a beautiful Samoan coral reef in the image behind me, as well as deep sea fishes and coastal fishes here in California. Actually, just in a few days, I'm heading out to sea to work with a team of researchers here at Scripps Institute of Oceanography, studying deep sea midwater fish right here off the coast of California. And I think none of this could have really been possible if I didn't have a kind of a general interest in diversity of form, diversity of life. I think in terms of things that may have influenced that, most significantly, when I was a kid, Pokemon happened to come out right at the right time. And, you know, there you're focusing on the diversity of those organisms in the game. And that kind of really sparked this interest in studying, oh, well, there's a lot more of them and they're a little bit more interesting in real life. So yeah, thanks.
Oh, thank you so much, Ben. Next, we have Dr. Sunny.
Hi, I'm Dr. Sunny Fugate. Sorry if that's a lot. I work for the Space and Naval Warfare Systems Center, now called Naval Information Warfare. And I lead up efforts that are looking at sort of novel methods of protecting computer systems and protecting the users that depend on the systems to do their jobs. So we currently are exploring all kinds of novel methods of basically sort of pulling the rug out from underneath attackers. So attackers on our network are often unfettered. They're good at hiding. They're good at finding defects, in computer software. And the defenders are faced with a really, really hard challenge, which is that they have to sort of like patch all the holes in the dam all the time. Because if any one of these holes in a dam is breached, then eventually, attackers have sort of free roam and free access, to systems. We've seen recently that this is still a problem. It's not a solved thing. So recent hacks, within medical record systems, say, for example, here in San Diego, that's happened recently. All of these kinds of sort of problems need novel defenses. And I'm really inspired by the defenses that biology uses. So things like mimicry, where one organism can pretend to be something more dangerous or less enticing. So, for example, the butterflies with the eye-shaped patterns on their wings, making a bird that might otherwise eat it think otherwise because, oh, look, what are those big eyes looking back at me? Something sees me, maybe I shouldn't do this. Similarly, we're sort of like trying to build sort of decoys and mimicry into computer networks so that an attacker, if they look at a bunch of systems on a network, they might see things that are vulnerable. They might see things that look highly protected, and they might see things that look like a mixture of these. And if they know that we might be using mimicry, then they might take pause and not necessarily go after the weakest system on the network, because that could very well be a decoy, just waiting for them to interact with it. And then once we detect that attacker, we might kick them off the network. So that's the kind of thing that we're currently working on. We also work on other kinds of things that kind of relate to the biodiversity that Ben mentioned. So we try to think about how we can make software less vulnerable by making it unknowable from the attacker, in the same way that two different organisms in the same population might have different immunity. So we can give software the same piece of software. So we can both be running the same software, does the same thing, but they don't necessarily have to share the same underlying structure. So they can have different immunity to viruses, computer viruses, and other threats. So that's the kind of stuff that I work on. Growing up, I was definitely inspired by science fiction. I'm an avid sci-fi reader. I'd love to someday maybe think about becoming an author as well. I've always thought about that as a good pivot from working in the defense industry. Read a lot of Heinlein growing up and Isaac Asimov, and then one of the things that got me into thinking about a career in more of the cyber field is the cyberpunk genre. And so I really love the work of William Gibson and Neil Stephenson, and more recently, Cory Doctorow. So they've been super inspiring, and I feel that the whole field of science fiction and fantasy is one of the things that really sort of does, at least for me, drove me toward fields in science and engineering, and I applaud that entire field for being so inspiring. So thanks.
Gosh, thank you so much, Dr. Sunny. That's awesome. Well, I would buy your first novel. So there you go. Next, we have Dr. Alyssa. Alyssa, you have the floor.
Hi, everyone, and thanks so much for having me today, and thanks to all the other panelists. As Karen said, my name is Alyssa Griffin, and I'm a researcher at the Bodega Marine Laboratory. And at the Marine Laboratory, I do marine geochemical research, which is basically looking at the geology and the chemistry of rocks in the ocean. So I love rocks. They're really great. And if you don't think so, go check them out. You can just go outside and look at them, and I'm sure you'll find some cool looking ones. But specifically, I look at rocks in the ocean, and I'm really interested in how rocks and minerals interact with ocean water and control things like our climate. So you might not think at first that rocks have anything to do with our climate and the temperature on Earth, but in fact, over really long periods of time, they actually control and sort of are a dial knob for the amount of carbon dioxide in our atmosphere, which is directly linked to the temperature of our planet. And so I'm really interested in looking at how these interactions have changed over time. So one way that that's happened is that as humans continue to increase carbon dioxide in the atmosphere, some of that carbon dioxide has actually entered into the ocean and has made the ocean slightly more acidic. And that's concerning for some organisms because the materials that they make their skeletons and their hard parts out of actually is really sensitive to that increased acidity, and it can actually make them start to dissolve. So if any of you have ever taken a Tums before and eaten a Tums, it's the same exact reaction, and it's actually the same material. So a lot of organisms make their hard parts out of a material called calcium carbonate. And if you look on the back of a Tums bottle, active ingredient, calcium carbonate. So it's the same thing, same reaction, except happening at a global scale. And so I'm really passionate about reversing and mitigating the impacts of climate change. And in order to do this, I like to look at different environments and ecosystems and how those changes in ocean chemistry are impacting local organisms living within those ecosystems, especially in coastal regions, because as humans, that's where we most directly interact and benefit from the resources and really the beauty of the ocean. So these are all the things that I'm really excited about and would love to talk about more as we move forward with the panel and Q&A. And I also really, staying on theme, I also love science fiction and fantasy. And I think the reason I really love them as genres is because anything is possible. And to me, that's the same with science, right? Like really the limit is our creativity and our ability to ask questions and say, is this possible? Is this something that we can do, that we can accomplish? And it's interesting to see how some things that seemed like sheer science fiction maybe 40, 50 years ago are now things that we use in our everyday lives. So yeah, I think that's why I'm really passionate about science and science education, and also really enjoy science fiction and fantasy as well. So thank you so much.
Gosh, thank you so much, Dr. Alyssa. I'm loving everybody's, everyone's sharing so far. This is fabulous. So thank you. Next, we have Sara Huber, also known as Callie Waterburn.
Hi, everybody. My name is Sara Huber, and thanks for letting me be a part of this exciting group of people, Karen. I am an engineer with California State Water Resources Control Board up here in Sacramento. So I'm originally from San Diego, which is where I know this panel and a lot of folks around it. But I came up here in order to help implement state policy around the topic of water quality and environmental protection of not just the endpoint, the receiving waters, but the entire watershed. I'm a member of the Division of Water Quality, and in our Strategic Stormwater Planning Unit, it's my job and my team's job to implement a strategy that we call the Strategy to Optimize Resource Management of Stormwater, lovingly known as STORMS for short. This is a really long acronym in order to basically talk about water, not just in piecemeal form like drinking water or wastewater or flood water, but one water, and recognizing that it's a precious resource that here in California and around the world can be very limited. And so as an engineer, I am trained to think about the design and the planning and construction of infrastructure that will let us capture, harvest, and use water in a variety of different ways to protect not only the needs of our society and human development, but the needs of all of our fish, fowl, environmental relations, and plant life and everything that makes up this Earth planet. Everything is integrated and interconnected. And so my job is to think about how to not only do that sustainably well now, but in the long term. And one of the things that I do as an engineer is talk to a lot of scientists, geologists, and other technical folks on my team. So I get to think about the nuts and bolts of how things work. And my team then asks me the scientific method questions: who, what, where, when, why, how. And that why is actually a really big part of the equation that is really important, because it shapes how everything is connected and how are we knowing and validating that things are going to get better because of a project. Because if we're not improving things and making things sustainable for the short and long term, we probably shouldn't push for it too hard. So my job at the Water Board is to think about things in big, small, short, and long term. And I focus really on the environmental side of the water world. Things that I'm inspired by, obviously, is a lot of sci-fi and fantasy. I grew up watching a lot of cartoons on TV, including things like Justice League, and was really inspired by Poison Ivy as a kid. So when I had the opportunity to come up here and join organizations like the League for Hope, which goes into hospitals and engages with youth on topics of science and medicine and things like that, I chose very inspiring to me characters to represent and embody. So Poison Ivy, being also a scientific background individual, really has influenced me from the short and long term. And actually, it's one of the reasons why I call myself Cali Water Gal. I was gifted that name back in college, and I sort of put it on as my own personal superhero persona to make sure that I'm always thinking about my purpose and my passion when I'm doing the grind of the work. So that's my story.
That was wonderful. Thank you so much, Sarah. That was fabulous. Next, we have Dr. Lisa.
Hi, everyone. Yes, so I am Dr. Alyssa Zeigler, and I'm also at the Scripps Institution of Oceanography, as well as the J. Craig Venter Institute. And I'm a viral ecologist that primarily studies viruses in marine ecosystems. And so what do I mean by viral ecologist? So you guys all know probably a lot about virologists at this point, and those individuals typically will study different aspects of a virus, and oftentimes human viruses. Well, I like to study viruses that infect single-celled organisms. One, because they're actually the majority of viruses on our planet. There's actually very few when you think of the breadth of viruses out there that infect humans. And they have really important roles in all aspects of our life that we often don't think about. So in the marine system, I study two main energy regimes. So the surface of the ocean, where we have photosynthesis, right? So energy coming in from the sun. And then I also study the deep ocean, so the bottom of the ocean at hydrothermal vents. And this is where we have energy, so chemistry, percolating up through the crust of the earth. And that energy is taken up by single-celled organisms and transferred. And so I study the viruses that infect these very important organisms in these two very cool energy regimes. And in fact, I've actually taken a ride on the submarine that's behind me, which was absolutely incredible, and gotten to see the bottom of the ocean one time. I'd love to go back. Hint, hint, funders. And so what we really look for is what their role is, and they play a very important role in the transfer of this energy. So getting the energy dissipated out to other organisms up the food chain, and really they also are very important typically in creating a very healthy ecosystem. So the turnover of organisms is actually very important. And so, you know, obviously, just like everyone else here, science fiction and everything has played a role in multiple different ways in my life growing up. And, you know, viruses included in pandemics, which maybe now is not the right time, but I do like these kinds of things. I always have since I was little. It's a little, most of it out there is doomsday because it is scary, and that's definitely something to think about for sure. But since I've been studying them, and since I've been studying really what I like to think of the flip side of viruses, I think it would be fun to see more of that in the science fiction moving forward, because they do have positive impacts, and there is so much about them that if we could really harness, we could learn so much more. So they are, in my mind, just, there's just this incredible simplicity to them. They're beautiful, yes, in structure, but there really isn't a lot to them when we think about proteins and genomes and sizes. They're usually very small, but yet they have these phenomenal aspects to their life. They're technically not living, but their life roles and what they can do, both negative sometimes, but also positive. So I think that that's just amazing. And I would love to see maybe more of that moving forward for viruses.
Thank you so much, Dr. Lisa. We next have Angela, who you are up.
Awesome. Yeah, hi everyone. So I'm Angela Zoumplis. I'm a grad student at Scripps Institution of Oceanography. I study microbes in kind of extreme environments. And one place I've been to, which is really awesome, is Antarctica. And specifically the dry valleys of Antarctica, which is one of the coldest, windiest, driest places in the world. And it just has all these really exciting features. So it's dark for 6 months out of the year, of course, freezing temperatures, right? But so the dry valleys is this place in Antarctica that is basically devoid of a lot of water and ice. It has these permanent lakes, and it also has just a variety of really, really cool features. So I'm just super happy that I've gotten, my little grad school career to go down to such a really cool, interesting place and look for life that is in super inhospitable conditions, and just general what's there. These are the questions we try to ask, like what's there, how are they surviving, and then can we use also some of those adaptations for human use, in industry and other places. So in my background, as talked about the exciting features, this is one. It's called Blood Falls, which is this just red waterfall spilling out of this glacier, and it sporadically flows, and it's thought to be an ancient marine lake in the middle of a polar desert, and then it again just sporadically flows out. That red color is from the iron, so kind of like blood a little bit, and so we look at, is there anything that can survive in there, and what is it doing, and finding a lot of really, really cool stuff that really pushes what we know about life and what life can adapt to. So of course, this has a little bit of a astrobiology, we're looking for life beyond Earth, going to all these really harsh places for life. So I've been inspired, of course, by Star Trek and Star Wars and anything, anywhere where there's, other worlds and habitable worlds. And more recently, Frozen 2. Frozen 2 is a great movie. Yeah, good stuff.
Thank you so much, Angela. Last, we have Chris Neuhahn, who is an Emmy Award-winning animator, producer, and director and writer. And Chris, can you please tell us a little bit about yourself, and then also how in your past projects you might have used science and worked maybe possibly with some researchers on developing projects. So you have the floor.
Oh, first, it's amazing that I'm the only person here that looks like an ocean explorer, considering the group that I'm surrounded by. And all of you sound like you're doing something vaguely to save the world, and I'm not. So yeah, as Karen said, I've worked in animation since 2000-ish. I've worked for Nickelodeon, DreamWorks, and currently I'm directing a new Lego series, which doesn't have any science to it at all. Fantasy, yes, but not science. And I too am a lover of science fiction. From watching Star Trek, which I still blown away that I liked it as a kid because it's so slow, but I still like it. And obviously Star Wars and just about everything else that's come along, even when it's terrible.
Oh, thank you. Thank you so much, Chris. All right. Well, we have a little bit of time now for us to do a little bit of Q&A, and then also just to have it seems so funny to call it a roundtable conversation on Zoom, but I'm going to switch us now over to gallery view. So we have, we can see each other's faces a little bit better, but I'm just going to start calling out a couple questions. And then also, if anyone also has any questions you'd like to ask one another, or Chris, if you'd like to ask one of the scientists a question, please jump on in. We've got about 10 minutes, and I just want to take this time to talk about, the love of science, science fiction, kids in science, and biodiversity, which I feel like I have heard so much, brought up. So, but the first thing that I had as a question is, and this would be for anyone, is what is the coolest thing you discovered as a scientist? I'm gonna throw that out there. I know you gotta think about that, but what's one of the coolest things you've ever discovered? Ben, do I put you on the spot?
Yeah, I guess I can jump in because mine are very straightforward in that, I have participated in describing, probably like 7 or 8 species of fish at this point. And none of those I myself discovered. I worked with people or came in to help them with those discoveries. But even in doing that, you're still telling people about an animal that nobody's ever recognized as a different species before, and that discovery of it in and of itself is very exciting, and being able to share that with the people, with the community and people all over the world.
Do people ever dispute whether something's actually a new species?
Oh, for sure. Yeah. It's definitely not written in stone. It's things are argued left and right.
Yeah. Our field for the microbes, so single-celled organisms or viruses, you have to go through a pretty hairy process in order to usually get them fully described before you can say, I'm going through it right now, so there's a little stress. A couple things before you can give it a name or anything like that, which is good. They're trying to make things sort of run, and so that everything has sort of the same structure and how it's characterized, but it can be pretty tricky sometimes to actually get that far.
Surprisingly, in animation, we have that too, because if you come up with a character name, they go compare it to every property they can find where they might put that property and make sure that you're not stepping on anyone else's IP.
Yeah,
You'll discover this, Sonny, when you go to write a book, which you should not wait for. There's never the right time. You just got to get into it.
Sunny, when you write are you even thinking about what you might want to write about? Will it be AI? Will it be computer related, or will it be, could it be a romance or a cookbook or?
I've always thought sci-fi would be where I'd want to land, but I think I'd want to pivot to maybe fields that I know less about, and then draw from that sort of cool multidisciplinary space in between the things I know and the things I don't, because I think that's where, at least for me, that's one of the fascinating things about being in science is those sort of spots where I can reach out to my peers and really sort of create a bridge between fields that, logically don't seem to have a connection, but there's always really cool stuff, the more you dig. So that's,
I'll be very curious to talk to you after you get into that and see where you find that balance of being accurate and being entertaining, because that's the big challenge for introducing science into, like I said, when we were talking before the panel started, in Penguins of Madagascar, every bit of science that's ever discussed is made up. There's one character builds up too much psychotic pressure that tells you how accurate it is. Although we did have a whole episode around the Higgs boson particle, but I'm sure that wasn't accurate either.
You're going to have a lot of people fact checking Penguins in Madagascar now.
Oh, it already exists. There's whole forums of people talking about what we meant by a particular scene, and we're like, we didn't.
Well, another question that I have here is this is an educational panel also for kids to be inspired to learn more about science and to question and to hopefully become future scientists. Would any of you want to comment about any advice about any kids, who may be interested in entering into your field? For example, Sara, if someone were interested in becoming a water engineer, what do you think they should do in high school or even going into college? Was there a path you followed, or?
That's kind of the beauty of my particular path, was that I was always in sort of the right math and science classes, but I honestly wanted to become ambassador to Spain. My interest was policy and influencing how things were put together from like a thought process, but I never really had a personal interest in building things. So really it was all about the right moment, the right discovery, the right passion that flipped the conversation for me. So if you're interested in getting into sort of a hands-on potential industry, I would say engineering is a great midway ground, because you can go out in the field, you can do construction, you can design things on paper if you're the creative type to potentially have played with Legos as a kid, or even now as an adult. There's so many different things that you can do, but the real fundamentals are math and physics in particular. But depending on what aspect, you can go into a whole bunch of different arenas, up to and including like electrical engineering. So it's a very diverse field, and it's all about a type of thinking. Much like science, it is a very systematic approach.
I was hoping you were going to say start with the hose in the backyard and start spraying everything down.
Oh no, that's my time right now. I'm playing with water at home during COVID.
So I do want to ask this, just in your various fields, have you ever run into a situation, I'm sure you have, where you've been told no or discouraged, or just, hey, you're following the wrong path, but you knew in your heart, actually, I need to pursue this because I think there's some truth to it. I mean, I do believe as scientists, all of you have hypotheses, when you test those hypotheses, but as you were mentioning before, I'm trying to prove that this one new thing has been discovered, and somebody may doubt that. Like, how do you deal with that? I'm just kind of curious and anyone, please answer. When you're told no or that you're wrong, how do you continue to pursue that?
I mean, I've definitely been told no a lot. In all kinds of things. And I've also gotten things wrong, and that's okay too in science. You're not always right. And sometimes you do have to admit that you're wrong. And that's okay. And I think a lot of science is actually repetition, and that you do something and then you have to troubleshoot it and troubleshoot it and troubleshoot it and finally get to where all the variables and you're doing it correctly. But I've also been told no and not given up, and then things have worked out as I had thought in various different projects. I think it actually might be a problem of mine, because most of my projects, and why I study viruses and why I've gotten here, it's been sort of corkscrew, is because they're so challenging to study, actually. I mean, I talk about them like, oh, this is so great, we know everything about them. It's hard to sample, it's hard to get there, it's hard to know what you're looking at, it's hard to sequence them, it's hard to process them. They are the most difficult things, almost impossible to grow. So even what I study is telling me no all the time. But one example that worked out in my favor was some funding from astrobiology, NASA, and they told me no, and I was like, no, we really need to do this. And they did shrink my budget and shrink my time, but it actually turned out that yes, we found a new virus, we are still working on the project, and yeah, it went forward. So, but yeah, I was so sick of hearing no. I was like, nope, I'm not listening. But I don't know.
When scientists say no to funding agencies is like a new genre. It's like, I'm sorry, we're rejecting you. You're not. Yeah, that's great.
Yeah, that's science fiction, right? That like
It's only worked once. So.
I just wanted to jump in too, because Karen, I know your question was more about like the scientific process and the scientific method, and really being persistent in terms of your projects and your research. But I also just want to encourage anybody watching the panel that, science is for everybody. And I think all of us here have experienced, more broadly being told no, or that we didn't belong, or that, we weren't in the right spaces or with the right people. And I just want to say that, yeah, if science is what you're excited about, like, you can do anything and everything that all of us are doing. And even if folks tell you no, or you can't, or you're not made for it, don't listen to them, because anyone can do it. So I really I wanted to like broaden out with your question a little bit, because there have been a lot of times where I've been, the only or the first in a lot of rooms and spaces in science. And it's just persistence, and it's believing in yourself, and really, pursuing your passions.
Alyssa, thank you so much. That actually was going to tail end the next question I was going to ask. And I love that you said that, because I think that is absolutely so true. And just as I am a mom of 3 children, and as a parent, you want to push your kids forward and tell them you believe in them. And, they're going to still get rejected. They're going to apply to places they're going to, and it's all about finding new spaces and challenging old views and moving forward. And I absolutely love that. I love that you shared that. Thank you so much. And we actually have to wrap it up in just a couple of minutes. I can't believe that this time went by so fast. And I just, does anyone else have anything that they would love to add? Any words of inspiration for future scientists out in the world? Please jump in. I would love to have you share.
On the fiction side of it, if unlike all of you fine folk, save your money, don't go to school.
Oh.
Obviously everyone needs to make their own choice, but the amount of education you can get from YouTube, and just doing life drawing and stuff like that, if you want to be an artist, and studying film, which you can do with a Netflix account. You can spend a couple grand on a computer and maybe a subscription to something like Udemy or one of those places, digital tutors, and walk into a job that already pays pretty good, not in debt. Obviously, you don't get to show up at the Scripps Institute and go, hey, I watched a YouTube video, but in art, you can.
Oh, thank you, Chris. Oh, go ahead.
To jump off of that, I would say, yeah, I mean, I think there's all kinds of things about school, but there's even a lot in science where you don't necessarily need to go to a traditional four-year college or other things, that you can still have access to different positions, different jobs, different what you want to do in the future without being daunted. And while I would love everybody to come to Scripps so that I get to work with you, I think it's important to also tell people that there's always avenues forward. Just keep moving, find what you like, because if you don't like it, you're going to be stuck doing it for a lot of hours every day, and that's really not fun. So, I mean, I love what I do. It's awesome. And I just think there's a lot of different avenues.
And one other thing on there is that at least once you get past the undergraduate level, at the graduate level, in a lot of science fields, you actually get paid to go to graduate school. Not very much, and that's your full-time gig, but you're not paying for it.
Oh, that's awesome. We need to have a panel just to talk about that. That's fabulous. So I just want to thank everyone for joining us today for the More Science in Your Fiction panel. And I'd also like to thank Comic-Con for having us this year for Comic-Con at Home 2021. We just want to wish everyone out there health and wellness, and best wishes. And hopefully, next year in 2022, we'll be able to gather in person. But in the meantime, we hope everyone enjoyed the panel today. And as Jean would say, keep sciencing, right? Question everything. So, all right. Thank you very much, everyone.